with all of these, the very first thing we're going to do is say that trying to factor this is probably not the best idea. Factoring really only works a very small percentage of the time. So we're going to just say factoring didn't work, so solving for 0 here is not something that I can do. Instead, I'm going to move the 32 to the other side. And now I have x squared plus 4x equals 32. So that's this first step here. It says move constant term to the right side of the equal sign. That's the 32. The 32 is a constant, right? There's no variable. Now, in big bold letters here, there's this little exception. This happens sometimes. If a is not 1, you have to take this extra step. And we'll talk about that later, but in this case, a is 1, right? What I mean by a, we've said this before, ax squared plus bx plus c. If you need to write it at the top to remind yourself, you can do that. So a, the very first coefficient, it's a 1 here, so we're good. That saves us a little extra work. So that's the first step. First step's pretty easy. Second step, here's where things get a little bit weird the way that it's written. It says, find the term that completes the square on the left side of the equation. And you're going to add that term to both sides. Now, that doesn't make a lot of sense, but this part here, divide b by 2, then square, that's what you're actually going to do. So what I want for you to do is look at the equation that we just set up. Which number is b? 4, right? So here's what we're going to do. We're going to divide b, which is 4, by 2. What's 4 divided by 2? Okay, so I'm just cutting that middle number in half. Then square it. What's 2 squared? 4. So in this case, we got right back where we started. Not going to happen often. So you're going to take that middle number, 4, cut it in half. Whatever answer you get, you're going to square it. Now this number is what I'm going to add to both sides of my equation. So I'm going to take this 4 here, and I'm going to add it to the left side. So it becomes x squared plus 4x. I'll do it in a different color here. Plus 4. And on the other side, I already had a 32, and I'm going to add 4 to that side also. So what I've done here is I cut b in half, I squared it, this number, and it always works this way. This number, half of b squared, when I add it to both sides, it has turned the left side of my equation into something that can be factored. And when it's factored, it's a square number. It's something times itself. So from here, we're going to factor what's on the left. So this is where we use our x method. I'm multiplying to make 4, but I'm adding to make 4. And my denominator is 1. What two numbers would do this? If you multiply them, you get 4, and if you add them, you get 4. Heard a lot of people say it. 2. Now, if you don't get this, if you don't get the same number on both sides, they're both positive 2, or they're both positive 3, both positive 5. If you didn't get the exact same number on both sides, something's wrong. You've set this up wrong. You should always get the same number on both sides. That's why we're calling it completing the square, because 2 squared made 4, and if you add them, you get 4. So what we have now is on the left, we factored this to make x plus 2 times x plus 2. You agree? We've got some questions. Spencer? They will not always come out positive, but they will always be exactly the same. Good question. Then you made a mistake. They should not be one positive, one negative. They're either both positive or both negative. They should be exactly the same. Alright? So in this case, we got x plus 2 times x plus 2. But when something is multiplied by itself, what do we call that? Squared, right? It's something squared. So we're not going to write it like this. We're going to write it like this. We're going to say x plus 2 times x plus 2 is x plus 2 squared. Hopefully everybody agrees that's the exact same thing. On the other side of the equation, it's really simple. On the right side, we had 32 plus 4. What's 32 plus 4? 36. Okay. all of that work is setting everything up. We haven't actually started solving anything yet. From here on out, every step we do is solving to find out what x is. So before we do the rest of this, are there any other questions about how we got to this point? So we moved 32 to the other side, we cut b in half and squared it, and then tacked it on to both sides of the equation. We factored the left to get something squared, and we added the numbers on the right to get 36. You will always be able to factor this on the left if you've done it correctly, but there will be some situations where you end up with fractions that we'll be talking about later, where we're going to actually develop a shortcut where we're not actually going to write out the factoring every single time. There's a way to just jump straight to this. Okay, so now that we have everything set up, let's start actually solving things. Now, what I want to get here, and I'm just going to rewrite the same thing, is I want to get x all by itself, but I've got a couple things that are in my way right now. I've got an exponent on my parentheses, and I've got a 2 here. Because the exponent is outside the parentheses, I'm actually going to try to take care of that first. So who can remind us, we said this on Friday last week, what can I do mathematically that will cancel out this exponent? What is the opposite of squaring something? We had this on Friday. Well, square rooting. So what I'm going to do is I'm going to write down that I'm taking the square root, and whatever you do on one side of the equation, you do on the other, so I'm taking the square root on both sides. And here's what this does. This makes the rest of this really easy. Square root cancels squared. They are exact opposites, which leaves me with x plus 2. On the right-hand side, the square root of 36 is what? 6 and negative 6. Remember, square roots have both a positive and a negative answer. So the square root of 36 is positive and negative 6. Well, that's two different things, right? So what I'm trying to do now is I want to figure out what number could I plug in for x that when I add 2 to it, I get positive 6. And then another number that if I add 2 to it, I get negative 6, which means we're going to solve two different things. I'm going to solve x plus 2 equals positive 6, and I'm going to solve x plus 2 equals negative 6. And this should give me the answers that I'm looking for. In both cases, all I'm doing is subtracting 2 on both sides. So 6 minus 2 gives me positive 4. Negative 6 minus 2 gives me negative 8. And those are my two solutions. And these are the solutions to the original quadratic equation that we had at the beginning, which means that it's not just me solving for 6 here. Because of all the work I did moving things around, this ultimately had me finding the numbers that if I plug these into the original equation, they make the whole thing equal 0. These are my x-intercepts.